The average person consumes around 13 teaspoons of added sugar every day. That might not sound like much, but your body was never designed to handle that amount day after day, year after year. And the effects go far beyond weight gain. Studies now show that high sugar intake is directly linked to fatty liver disease, insulin resistance, chronic inflammation, and accelerated damage to your blood vessels and brain. But here's what most people don't realize. Many of these changes start reversing within days of quitting sugar. In this video, you will see exactly what happens inside your body from day 1 to day 30 when you quit added sugar. What changes in your brain, your hormones, your blood vessels, and your liver, backed by the actual research, and why even 30 days can start undoing damage that has been building for years. Before we get into the timeline, let's be clear about what quitting sugar means in this video. We are talking about cutting out added sugars and sweeteners. We should also note that natural sugars in whole fruit and plain dairy are allowed because they come with fiber, protein, and micronutrients that change how your body handles them. With those rules in place, here's what happens to your body when you quit added sugar day by day. On your first day without added sugar, the most immediate change is in your blood sugar levels. For most people, a typical day looks like this: sugar or refined carbs for breakfast, a spike at blood glucose, then a crash mid-morning. Another spike at lunch, another crash in the afternoon, then more sugar or caffeine to fight through the slump, followed by another crash in the evening. One 2018 study using continuous glucose monitoring found that even people with supposedly normal blood sugar levels experience significant glucose spikes throughout the day, with levels reaching pre-diabetic ranges of 15% of the time. When you cut out added sugar, that roller coaster stops. Levels begin to stabilize, and your pancreas releases less insulin because there are fewer big spikes to handle. At the same time, your body switches to using stored glycogen for energy. Glycogen is your short-term sugar reserve, and it is stored with several grams of water for every gram of glycogen. As glycogen breaks down, that water is released, which is why many people lose a couple of kilograms in the first 24 to 48 hours. It is not fat yet, it is water weight, but it is a visible sign that something is changing. By the second and third day, your brain starts to protest. Your brain is wired to seek out sugar. Research shows that when you eat something sweet, it triggers a release of dopamine, the same neurotransmitter involved in reward and motivation. Animal studies have even found that sugar can activate reward pathways more powerfully than some addictive substances. Over time, if you eat sugar regularly, your brain becomes less sensitive to that dopamine signal, so you need more sugar to get the same feeling. When you suddenly remove sugar, your brain's left craving that dopamine hit. This is when people experience what feels like withdrawal. Common symptoms include intense cravings for sweet or starchy foods, headaches and a foggy, slow feeling, irritability, low patience, and mood swings. Unusual tiredness, especially in the afternoon. These symptoms are not dangerous, but they are uncomfortable. Your body is adapting to a new way of creating energy, relying more on fat stores and breaking down some amino acids into glucose to keep your brain supplied. If you can push through these first few days, everything starts to shift. Around day 4 to 7, most people notice that the worst of the withdrawal symptoms start to fade. Your blood sugar is no longer spiking and crashing multiple times a day, so your energy feels more stable. Instead of needing snacks or caffeine to fight through the afternoon, you can move through the day without that desperate need for a sugar hit. Sleep often improves at this stage as well. A large study of over 50,000 postmenopausal women found that lower sugar intake was correlated with reduced insomnia, though the exact mechanisms are still being researched. When your blood sugar is not bouncing high in the evening, your body can settle into deeper, more restful sleep, and you wake up feeling more rested. Your digestive system is also starting to adjust. If your old diet was high in sugary drinks, sweets, and ultra-processed foods, your gut bacteria are now getting more fiber and fewer simple sugars. This can cause a few days of bloating or changes in bowel movements, but for most people it settles quickly as the gut microbiome adapts. Somewhere between day 5 and day 10, something surprising happens. Your sense of sweetness recalibrates. One study had people do a water fast for 5 to 14 days and found that the threshold to detect sweet flavor was much lower afterward, increasing sensitivity to the taste of sugar. This happens because constant exposure to very sweet foods dulls your taste receptors over time. But when you remove that intense sweetness for a week or two, the threshold at which you notice sweet drops dramatically. Suddenly, a piece of fruit tastes incredibly sweet. Foods that used to taste bland now taste richer and more complex. And if you try something like a soft drink or a sweetened coffee, it can taste overwhelmingly, almost sickeningly sweet. This reset is one of the most powerful changes because it makes it much easier to stick with a lower sugar diet long term. You are no longer fighting constant cravings. Your body simply does not want that much sweetness anymore. By the second week, you start to see changes that are visible from the outside. Because you have removed a concentrated source of calories and reduced insulin spikes, your body can now access fat stores more consistently. Many people see a steady drop on the scale and a slight reduction in waist measurements by this point, especially if they are not replacing sugar with other high-calorie foods. Your skin can also start to respond. Clinical trials have shown that high sugar intake can cause acne lesions within 1 week, and after 10 weeks of a low-sugar diet, acne lesions significantly reduced. This happens partly because of sugar's effect on insulin and hormones. Reducing that load for a couple of weeks often means fewer breakouts, less puffiness, and a more even complexion. In the third week, the benefits for your metabolism become more pronounced. Here is what is happening under the surface. Every time you eat sugar or refined carbs, your blood glucose rises, and your pancreas releases insulin to move that glucose out of your bloodstream and into your cells. But when you eat sugar frequently over months and years, your cells stop responding to insulin as well as they should. This is called insulin resistance. When insulin resistance sets in, your pancreas has to produce more and more insulin just to have the same effect. Eventually, insulin levels stay high all the time, a condition called hyperinsulinemia. And those persistently high insulin levels affect almost every system in your body. You are stuck in fat storage mode, unable to burn fat for energy. Your kidneys are constantly told to retain fluid, which keeps your blood pressure elevated, and your pancreas struggles to keep your blood sugar under control, putting you on the pathway to type 2 diabetes. Research shows that it is estimated only 8% of US adults show no signs of metabolic dysfunction, meaning 92% are dealing with some level of impaired metabolic health. But when you quit added sugar for several weeks, insulin levels drop, and your cells become more sensitive to insulin again. Studies show measurable improvements in insulin sensitivity, lower fasting insulin, and better blood lipid profiles, especially when sugary drinks are removed. This is one of the most important changes you can make for long-term metabolic health. The hidden danger, fatty liver disease. Now we need to talk about the liver because this is where sugar does some of its most serious damage. When you eat table sugar or high fructose corn syrup, it breaks down into two simpler sugars, glucose and fructose. Glucose can be used by almost every cell in your body for energy. But fructose is different. It cannot be used directly by most cells, so it gets sent straight to the liver. Once it arrives, the liver has two options. First, it can convert fructose into glycogen, your short-term energy reserve, but the liver's glycogen storage is small and fills up quickly. When glycogen stores are full, the liver shifts to its second option, converting fructose into fat. Under normal circumstances, the liver packages that fat and sends it out into the bloodstream to be stored in fat cells around the body. But when the liver is overwhelmed by too much fructose, it cannot export fat quickly enough. Fat begins to build up inside the liver itself. This is how non-alcoholic fatty liver disease begins, a condition that mirrors alcoholic liver disease but is caused by fructose and not alcohol. And if you think this is rare, think again. A 2022 study revealed that 70% of people who are overweight have some level of fatty liver disease, and for those with obesity, that number rises to 75%. Many experts believe these figures are underestimates. The problem is that fatty liver disease is silent in its early stages. Most people have no symptoms. It is usually picked up by accident during tests for completely unrelated conditions. Why fat in the liver is dangerous. Once fat starts accumulating in the liver, it triggers a cascader of serious problems. The liver itself becomes resistant to insulin. Normally, insulin signals the liver to hold off breaking down glycogen when there is already plenty of glucose in the blood. But when the liver is filled with fat, it becomes deaf to that signal. Instead of holding on to glycogen, the liver starts breaking it down anyway, releasing even more glucose into the bloodstream, even when blood sugar levels are already high. This sets off a vicious cycle. Blood sugar climbs higher, the pancreas pumps out more insulin to bring it down, and that extra insulin makes insulin resistance worse throughout the body. Research has established that fat accumulation in the liver is the trigger point that drives insulin resistance, not just in the liver, but throughout the entire body, accelerating the pathway toward type 2 diabetes. One diabetes expert described it like this: Before the diagnosis of type 2 diabetes, there was a long, silent scream from the liver. So the big question is, will quitting sugar for 30 days actually make a difference? The answer is yes. And it can happen faster than you think. As soon as you quit added sugar, you stop the constant influx of fructose hitting your liver. Your liver continues exporting the existing fat, but it is no longer being forced to create new fat every single day. Multiple studies show that interventions that cut sugary beverages and high fructose intake lead to measurable reductions in liver fat and improvements in insulin resistance in as little as a few weeks. For some people, 30 days is enough to see real progress. For others with more advanced fatty liver, it may take longer. But here's the key thing. For most people, the buildup of fat in the liver is reversible. So what happens if you keep going beyond 30 days? The longer you maintain a lower intake of added sugar, the more you support better blood sugar control, better insulin sensitivity, lower risk of weight gain and fatty liver, and reduced risk factors for heart disease and type 2 diabetes over the long term. But even if you stop at 30 days, you come away with something powerful. You now know how your body feels without constant added sugar. You do not have to live sugar-free forever, but after a month of this experiment, you may find that you simply do not want to go back to the old normal. If you want to try this challenge yourself, pick a clear start date, define your rules, and track a few key metrics. Energy, mood, sleep, and waist size so you can watch your own story unfold over the next 30 days.